Yeah, Node.js observability in containers then. I suppose the first question I have is who's running containers in production today? Okay, so about 7 or 8, just about a third of you. Okay, does everybody know what containers are? Is everybody happy with containers? Some people not happy, well, that's okay. I do have a description of what containers are, so we'll look at containers. And then I'm going to talk a little bit about observability. So I've got some specific opinions on what I think observability is and isn't. So I'm just going to share some ideas on that, okay? And then we're going to look at some technology that's been sort of coming to the fore in some of the latest Linux kernels that basically allows you to dynamically instrument applications safely in production environments. In containers, therefore in Kubernetes, okay? And you can use this technology on public Kubernetes infrastructure. So it's quite interesting for people who are using public cloud, etc., okay? Seems okay? Everybody's still looking at me, which is okay. Right then, so I better go on full screen mode, or else my up and down arrows aren't going to work. Right, so what are containers then? So containers are basically the ability to run isolated processes within a single operating system, okay? And so you have a piece of bare metal or a server, a machine, you put an operating system on it, a Linux operating system in this case, and what that has features and functions in it that allow you to run specific binaries and libraries that can be shared then within specific applications, okay? So you can basically layer containers to share libraries and then deploy different versions of applications into each container. Well, that's what it allows you to do. There's good reasons for doing this, sort of specifically because your operating system is already started up, your startup time for this type of technology is super quick. So these are less than a second to start up usually, unless you're doing something quite strange in them. So you get a better developer experience when you have lots of different services that you need to consume, you need to use, and you need to run them either on your same machine or on your developer laptop. Okay? And then if you sort of think about where we were or where we are, or where we have been, should I say. So usually when you compare containers, you compare them against virtual machines, okay? So containers offer way better tenancy than virtual machines, okay? So the modern architectures that we have, when I use the often coined phrase microservices, but microservice architectures, where you have lots of separate services providing specific functionality, in that type of architecture, you can have a single machine with lots of instances of services on, as opposed to a separate machine and a separate operating system for each service. So we get, the customers I work with in IBM, we see sort of benefits of like 60-70% reduction in footprint when you use a container technology. So that means less overhead for management, better patch times, better day 2 operations because of that. Okay? So, does anybody have any questions on containers? No? There are t-shirts. Okay. Right, yeah, and sorry, I'll share these slides afterwards, but on most of these slides I've got links, so you can sort of download the deck and find out more specifically about what I'm talking about there as well. Okay? So, observability then, okay? So, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs, okay? So, observability is a property of the system. It's not something you do to a system, okay? So, having monitoring is not observability. When you have monitoring, you utilize observability to get to perform monitoring on a system, okay? So it's quite important that people get lost in the fact that, okay, we're now monitoring this system, therefore we have observability, therefore everything's going to be okay. And that's not actually true, because you can only monitor a subset of your output. Your observability, you want to be able to observe as much of the system, not necessarily all the time, but as much as you possibly can when you need to. So, like I said, observability isn't just monitoring. So I like to think of it as a sort of a continuum of the system, okay? So this guy, Pierre Vincent, did a talk. He's site reliability engineer in Cork for Populo. He did a talk in QCon, London, late last year. And he has this idea of observability is around managing or helping you to manage what the known unknowns are, but it should also help you when you have unknown unknowns in your system as well. And it's really it's a move from left to right on the properties of your system. Okay, so with the likes of health checks, this is sort of standard stuff that you put into an application. So the ability to be able to ping an endpoint and say, are you still up? Are you still managing to? Are you still alive? Can you still do things? Like, do we use health checks? People who are doing stuff in production? Yes, you're using health checks. It's all good. Some hands didn't go up there, but I'm looking at you folks on that second tier. Yeah. Okay. So then, so along with health checks, then we also have metrics. So we see the likes of people monitoring. Traditionally, you'd have had metrics on CPU, on disk. We're seeing that not be as important now, or certainly that's not necessarily the what people are looking after, applications are looking at. What metrics are used for, or we're seeing increased use for, is the likes of latency. What else are we seeing? Metrics for errors, the amount of errors that are coming out of the system, those types of things. So like application level issues as opposed to infrastructure level issues. And we're seeing alerts being sort of thrown up when things are running slow and when we're seeing a lot of errors in the system. And then, so that's sort of like instantaneous points in time, or point in time checks. And then we see people putting those metrics into databases. The likes of Prometheus is coming along in there. Using that technology so they can query alerts that have happened. People are trying then to also take the logs in as well, so there's log management specific technology, so when you get issues you can go in and look at your logs. There's log service providers, LogDNA is one that IBM uses, but there's log entries as well. We've done a lot of work with, I've done a lot of work with in the past, a Dublin-based company now with Layer 7. And then with all these events and alerts sort of popping up everywhere, what we're seeing is event management. So we're seeing technology now that's coming into the market that basically takes all these things and correlates them into an event management system. So IBM have an event management system named IBM Event Manager, which is very imaginative. But basically there's bits of, I don't want to call it AI, but machine learning that, like I say, can try, as different things happen up and down the stack, try and correlate that to give you a view when you're doing investigation. And then we have tracing. So this is sort of the newer topic here, where you want the ability to send a probe through the system and see what that looks like across all the different services that you're running. So Open Telemetry is the CNCF project where we're seeing a lot of activity. There's been a lot of different implementations over the past 4 or 5 years in the tracing space, but they've all sort of consolidated now into Open Telemetry. So that's well worth a look at as well. And then finally, and this is the bit that sort of interests me, is ad hoc instrumentation of the system. So no matter how much of these other things that you do, you will never have something that covers all the potential problems that you can get in production. So you need the ability to add ad hoc instrumentation into the system, okay? Peter, did I see a hand going like this? There, no? Is it for a t-shirt?
Break your train of thought, sorry. What's CNCF?
Sorry, the Cloud Native
Computing Foundation.
Computing Foundation. Thank you very much. Cheers. Yeah.
Just a...
Okay. So and this is really what I'm trying to say with this, with sort of these cogs in this brain here, okay, or the cogs in the brain. So to the left side of this diagram, you can get a lot of tools that help you out with that side of it. But more and more as you come over here, there's less and less sort of product type toolings, and it's more about applying your knowledge and your investigative techniques into the problems that you're seeing. Okay, and this, I don't see this ever, certainly as systems get more and more complex, I certainly don't see the the need to have a human being in the mix to do ad hoc instrumentation and understand the wider system, I don't see that being a problem that's solved anytime soon. Okay, and like I say, check out Pierre Vincent's talk. It's actually, I've modified this, so I've added these bits onto his slide, but he covers all those other aspects really, really well, and it's a talk in and of itself, as you can probably imagine. And I'm just trying to sort of glance over it really, just to give you some context. So this is what we're going to be talking about. This area, like I say, is what we're going to be talking about tonight, and we're going to be talking about technology called eBPF, so Extended Berkeley Packet Filters. Okay. So what is eBPF? Like I said, Extended Berkeley Packet Filters. It's WASM for kernels. Do you know what WASM is? Have you heard of WASM as a technology? Starting with WASM. Okay, so WASM is an instruction set, a sandbox runtime that's embedded into your browser that allows you to run native code from within a browser context. Okay, so that running code within a certain context is exactly what Berkeley Packet Filters are. It's fundamentally a reduced instruction set computer within a kernel, okay, and you can have multiple versions of these, and because it is a mini computer inside a kernel, you can, it's excellent for enhancing the kernel without having to do kernel modules, which I don't know how familiar you are with that, but that's a living hell in and of itself. So we're seeing a lot of people use this for lots of different scenarios, okay? So what is a computer inside a kernel, or whatever the layers were that I was talking about? So fundamentally, it's a set of registers where runtime data is held. There's a call stack that there's a limit to that call stack. So you can't just write the world's biggest program and drop it into a kernel, but there's a lot of flexibility with the size of that call stack. And then importantly, what you have is this area called maps, and what that does is allow you to do safe data aggregation within the kernel space. So you can write a program that processes events that are happening in the kernel, be they I/O requests, file system requests, and you have an area within the kernel where you can aggregate those and then produce them as an output afterwards. So it's really good for doing long-term analytics. It's not just sort of a one-off per event type thing. Okay? So I'm going to drill into my camera. Okay. So that's what the runtime looks like, but the sort of the overall architecture of eBPF, you write a user program, you generate that into eBPF bytecode. That is then sent into the kernel, into the static verifier. Okay, the static verifier, so eBPF runtime isn't Turing complete because that would allow you to basically blow up the kernel, potentially blow up the kernel. So it's not Turing complete. There's a subset of logic that you can use, and the static verifier ensures that you are using that subset of logic gates. That then goes into the Bpf runtime, and you have the possibility to attach to user statically defined types, K probes, which are kernel probes, U probes, which are user probes, trace points, and express data paths, which is a sort of a new networking technology that's within the Linux kernel. Okay, so you have all these APIs within the eBPF the Bpf runtime that you can hook into with your user program, so you don't have to bring all these different aspects of the system into your program up here. The facilities are already there for you, okay? And as I mentioned then, the Bpf map or the mapping technology is in there to store your data aggregations. And then when you run your trace, you basically get two outputs. You get an output, if you listen to events, and you just want things to happen on specific events, you get per event data that's echoed into user space. And then finally, once your trace is completed, it will, if you've asked for a statistic output, it will give you a statistics dump at the end of it. All right. So a demo. Thank God for that. So. So, but nobody can see this, can they now?
No.
Big.
Looks better.
Okay, so this is a very, very simple BPF program. And it's written in Python, and then you pass, where you can write it in C, or you can write it in Go, or you can write it in Rust. You can pass a specific program into the interpreter. Okay, so the Python is really acting as a scripting environment that lets you pull all the pieces together to make a script that you then go and give to BPF. Okay, and all we're doing in here is looking for kernel events for sysclone. So sysclone is it's like a fork, but it's not quite a fork. So it's not out of process, but it works like an out of process call. So let's have a look at what this does. Oh, actually, so I've added as well into this a debug 2. So every time that fork's called, or that clone's called, I'm just going to print whatever data is associated with that call. And I've added debug 2, so we can just see sort of the instructions before they are sent into BPF. So we just get an idea of what's going on there. So why did I do this? So all commands must be ran as sudo because you're in the kernel. So this is the, actually let's blow this up. Oh, no. Okay, so these are the instructions ready to be, as they are passed to the interpreter. These will then be taken in, validated, and compiled into an eBPF program. Okay? And then if I go into this, do some things and go back to my shell, you'll see that when I was clicking around and pressing return on the shell, it was firing a set of events. There's some other pieces there going on as well, whoever evince is, but I'm also catching all the bash activity within, all the clone activity within the bash shell. And every time that happens, I'm just simply printing out hello world. Okay? Any questions on that so far? A lot to take in. I appreciate that. Nope. Right.
Can you make maybe an example on when this can be useful? Like a real life case you maybe had already?
Yeah, absolutely. So I just wanted to give you a handle of that. What we're going to look at now is sort of a simple Node.js use case. Obviously, for a Node.js meetup, I wouldn't do that to you all. Coming to a Node.js meetup talking about kernels for 45 minutes. I don't want to be that guy. So, yeah, I will. Okay, and I will eventually get onto containers as well. Right, so where was I? So that was the Hello World demo. Okay, so what can you use this for?
We prevent this.
So, software-defined network configuration. You can do very interesting things in the network environment when you can inspect single network events. So a lot of it, where I'm seeing personally some interesting work done here is with, and I'm going to mispronounce it now, but it's Cilum, C-I-L-U-M. They are using it to, when you're on the same host and you're making calls between services within a pod environment, sorry, there's a lot of terminology there, but they, rather than go all the way down into the network stack and all the way back up on the same host, you can actually jump from one process into another. So you can like massively increase throughput if you're on the same machine using that type of technology. We're also seeing it used sort of lower down, but that's not really in my space, but we are seeing it in the infrastructure space. Ddos Mitigation, Cloudflare use this. There's a great post, did I mention it here? No. There's a great blog post by Cloudflare on how they use it for their DDoS mitigation. So when packets are coming in, they can inspect those packets, and they can, because they've got the map technology, they can aggregate those things coming in and look at it and go, actually, we're not going to serve this packet, or we're going to do this, that, and the other. So we're seeing DDoS mitigation. Intrusion detection, so we see We see the same use of aggregated, when you're taking aggregated metrics from a machine, say file access or strange file access that's gone on a machine or strange uses of a machine. They're using eBPF to get that data and then make decisions on whether they think there's an intruder on the system and those types of things. In firewalls, which is sort of the classic use for Berkeley, for packet filters, hence the name, but it's still used in firewalls. Container security, so in containers there's a lot, part of the container infrastructure's setcomp. Quite a lot of setcomp is written in eBPF, so a lot of the container security is done within this. And then obviously the bit that sort of we're trying to talk about tonight, which is observability. Okay, does that answer what were you thinking of? Yeah.
You mentioned with the Silum stuff, it divides going down the network stack and back up. Does that mean it's breaking the sandbox that a container provides you?
Is it breaking the sandbox? Yes, so you would do that from within a pod, okay? So we see, especially as we see a lot of sort of traditional workload be moved into containers. We see the traditional app servers being in there and all that type of thing, and that's where we're seeing that type of technology being useful. It's like not when you're doing sort of cloud native type stuff, but they are, and I'm definitely not in a position to talk in detail of it, but they are targeting the scenarios that you're talking about there, which is sort of out of pod. Like how do you do that securely? They are definitely looking at that. I haven't taken it for that hard a drive, but I know we're looking at it. Okay, so we looked there at Bpf, putting together a eBPF trace with the BCC or using BCC, but there's also a newer technology called Bpf Trace. And I'll give two examples now of tracing a Node.js process using the old technology and Bpf Trace, and we can sort of compare and contrast there. So both of them sit on top of libBCC, which is a library you can use to implement your own Bpf parser and create your own Bpf programs from scratch if you want, rather than using a set of tools and utilities. And again, these all sit on eBPF. Okay. So let's have a look at Node.js user statically defined demo trace. Okay. So in
Anton?
yes.
With the compiler, because the underlying risk machine is not Turing complete, does the compiler then modify the high-level languages?
No, so it sits on top of LLVM, and that has the facilities to interpret that to interpret your high-level language into the intermediate. Okay. So that's what gives you your bytecode, and then and there's no restriction on that. You will only get the restriction when you go and try and put that into the virtual machine, into the verification piece. So that's when it will say actually you're using parts of the language that you're not allowed. So if you have a for loop, it will identify you're doing a for loop here, and we're not having that. Thank you very much. And that will happen at the verification stage. So it will you can write it and. You will be able to compile it into a reduced instruction set, but it won't run, and your kernel will say, no, you're not having that. Okay? Right, yeah, so let's start a node process. So I have here this guy, which is a simple hello world from the about HTML on Node.js.com. Okay, so there's no mysteries in here. There's nothing up my sleeves, nothing like that. And what we're going to do is run this. Okay, so and that's started up the server on 3000, and it's giving me a PID of 4783. Okay, so what I can do is in the later versions of Linux, so of Linux over the past. Oh, go.
Increase the font. Could you increase the size of
The font? Yeah, of course. No t-shirts for that. Yeah? Okay, cool. Yeah, so running about basic HTTP server port 3000, and that's the PID that comes back from it. Okay. So in the later versions, and I say later, in Linux versions over the past 2 years, really, we can, and I will go up again. Oh. There's a facility called TP list, and I can pass in a PID of and this tells me, so in the first eBPF program we instrumented some the kernel, but all the applications that you run have instrumentation points as well, and these are sort of all parts of the standard, all parts of the runtime that Node.js uses. libp thread there, so whoever thought Node was single-threaded is going to have a bit of a shock. There's all the memory allocation moments that we have within there that are coming from libc. But importantly, what we have is Node.js has user statically defined types. So you have exposed in Node.js. You have when GC starts, when garbage collection started, when garbage collection is done, when the server's responded, when a client's made a call, both on network and on the HTTP stack. And right today, you have to specifically build Node.js with this in. So you have to compile Node.js with the dtrace with dtrace flags. But I'm hoping that we can start producing Node with these USDTs pre-enabled in it, and you can just get the Docker image. It's not that much of a fuss, really. So this is a facility that was put in for other operating systems, but it's great to see that Linux can finally start to use it. Okay, so that's fantastic. Let's go here, put it on there. No. Clear that off. And within here, I have there's a package that comes as part of BCC, which, and we'll have a look at it in a second, but it's basically Node.js HTTP server, and I give that a PID, and it will basically start monitoring the HTTP server live. So I'm basically asking the operating system to look at the Node.js process, find out what it understands about it, and then start monitoring on it. And because Node.js specifically has network hooks that I can get hold of, I can write scripts that can hook into those. So here's the hello world, so I can refresh that. And because I'm in a browser, it's done 2 requests. Obviously, it's gone off to get favicon, but it's got my path there. It's got my timings for it. So I can dynamically instrument the Node.js process without having to put any instrumentation within my application code at all. Okay, so that's super helpful. It's a very simple example, but it's super helpful to be able to do that type of thing when you're going to get problems, like I said, that you don't know about, and you need to do ad hoc instrumentation of the system. Okay, so let's have a look at that piece of code. Okay, so this is a lot more complicated now than the original hello world. So the structure is roughly the same, but I'm importing USDT now because I'm doing USDT probes. I'm importing system, I'm parsing out command lines, and this is where it gets a little bit hairy. So what you can see here is I've created a C program. So I've got a C program wrapped in text, and if anybody's been sort of doing JavaScript and remembers putting HTML in JavaScript and rinsing that out, like this feels exactly the same and just as good. Okay. So that's the program definition, and as you can, and the main part of that is parsing out the path, because the path can be sort of quite a large size. And then I've got some debug parameters as well. And then I start, when events are fired, this is my print statement, so sorry, it prints out the headers, and then while 1, so while true, this Python is going to keep in a loop, and every time it gets an event, it's going to print that out, okay? And that's what we saw in the output, okay? So that's 58 lines of pure joy right there, okay? So, like I said, there's two ways of doing this. This is, obviously you've got a lot of control here. You can't really mistake that, and you can do a lot of very, very interesting things here. But if you're just on the observability piece, or you just want to observe certain things, you're better off really looking at Bpf Trace, okay? So this same program, or roughly equivalent program in Bpf Trace is this. It's wall 9. So you say, I want a USDT probe, it's a HTTP server request, and when that happens, print HTTP server fired, and then print the method and the path, okay? And I pass in the arguments that happen on that event. So this is a lot more like what you would expect to be running, okay? So I should, all things being equal, be able to run that against this as well. Sorry, what did I call it? So I tell it the PID I want to do, and then I can pass in that hello.bt, wasn't it? So give me some output. I've attached one probe, so it's attached to that HTTP response. And when I run my request again, it should still attached there. It's printed out that HTTP server request fired, there's the path, and there's the get. So you can use both ways, but like I say, for observability type scenarios, definitely the Bpf Trace. Okay, how am I for time, by the way? I feel like I've gone on for ages. I probably have.
What are you doing? You're doing good. Yeah. You 10 minutes?
10 minutes?
Yeah, is that okay with you?
Yeah.
Yeah.
Okay. I thought you said I've been on for 10 minutes. It's been way worse than that. Okay, so go to full screen mode again. So how does this relate to containers then? Okay, so back into what I was talking about at the start, which is you've got a container, it's got a Node.js process in it, and it's in the sad place in production. We don't know why it's in the sad place, but it's in the sad place. And you're in a Kubernetes, obviously in a Kubernetes environment, okay? So personally, my first reaction to this is, sure, I'll just SSH into the box, and I'll run some of the magic that you've just seen, but directly against the Node application. Right? That's okay if it's all your stuff. But if you're on if you're in a shared environment, be it a public cloud environment or in an enterprise environment where your Kubernetes worker node is shared with a lot of other applications, you're not going to be given permission to go and log in to the worker node and go and run all the scripts that I've just shown you. Okay, so what you need is a facility that utilizes Kubernetes and the abilities of Kubernetes and doesn't break what your sysadmins and your access permissions for the environment. So, folks who are familiar with containers would be familiar with kubectl. That's how I'm going to pronounce it, by the way. No t-shirts for anybody who pronounce it differently. And what I've been working on is extending this kubectl trace. So kubectl trace allows you to run eBPF traces against within a worker node environment, but it didn't handle Node.js at all, really. It didn't handle the USDT bits that we looked at or anything like that. So that's really what I've been at. And what it does is, as you can see, it provides a set of facilities to create a job and then get the logs from the job that you've created. So it's going to take that eBPF program and it's going to pass it into the Kubernetes control plane, and it's going to ask Kubernetes, the Kubernetes control plane, to deploy a specific container for Bpf Trace and pass your program into that, and that program will interact with the worker node to allow you to instrument other containers that are held within that server. Okay. Now, and the beauty of Bpf Trace within the kubectl environment is there's a whole service permissions framework that's been baked into it. So you can't necessarily, you can set permissions on, so you can't just go and run Bpf Trace against all the other processes that are on the server. It's got to be processes that you own. So it's like, it's got the ability to be ran safely in sort of production environments from that perspective. Okay. So that's pretty much all I wanted to say on that.
Sorry.
Yeah.
I kind of get lost at a certain point on the last example, and the one with the Bpf trace.
Yes.
You were not specifying a PID. Were you or not?
Yes.
You were.
I did specify the PID.
So, when I'm in the container,
Yes.
and my application is running the container,
Yes.
the PID that is in the container
Yes.
is not the actual process that is outside.
No, it's not. No.
And you're saying that those, let's say, lighter blue boxes are different containers,
Yes.
because the job is running a different container,
Yes.
and this guy is another container.
Yeah.
How can I get the PID within this one? How can I get from this container into the other?
So
What
this,
do you mean on PID? How can I address exactly that one?
the Bpf Trace asks the worker node to go and do things. So the worker node knows the PID of this, and you have permissions to go and see that.
There's not the straight Bpf
But you're not going Bpf Trace into this. You're running the commands that we ran previously. You're running them on the worker node,
Oh.
but you haven't SSH'd in to run them.
And
You've
then
asked,
he knows about the processes that are in the C group in the container that is running, and you can inspect those and find the thing you want.
yes.
Cool.
Yeah.
It's pretty slick.
Okay. I'm glad you like it. I quite liked it as well. That is not my work, by the way. The only thing I've done is added like a little parameter on that, like I say, just allows you to do this thing, but with no processes.
And no privilege, right? No, does it have to be privileged as a container?
Does the sorry, I'm not following you. Mean
No, when containers can be run as normal containers or
Yep.
as privileged containers, which has superpowers, like pseudo powers, like they can access.
so? You don't have to be. Do you have to be sudo within the container? You probably do actually. I'd have to check that for you.
Bpf Trace probably has to be
Yes, but I haven't looked
privileged
into that.
container. So let's say the cloud providers or whoever is providing you the cluster
Yeah.
must let you run that thing as privileged,
Yes,
which is not always the case.
but we're in luck because I know a cloud provider. to run privileged containers on your public Kubernetes
This was
infrastructure.
well played.
Yeah, absolutely. I get a t-shirt now. Excellent. Cool. Yeah. So what I've done is, for this example, I've published an instrumentation framework. Geez, about 2 years ago now. And really what it allowed people to do was write their own instrumentation technology for Express, depending on how they wanted to sort of take in events from their Express application. So over the past month, I think, well, about a month ago, not over the past month, about a month ago, I basically converted one of those to use USDTs. So you can use this technology for an Express application in containers in public cloud. And that's what we're going to look at now. So I think we're pretty much the end of slides now, but there's a bit of code to step through, right? So where do we start here? Let's start with the actual Express application. That's fairly easy. Okay, so this is a normal Express application. The implementation of how you instrument Express applications is provided by this Express Tracer module. And you use that Express Tracer module and pass it an implementation to it. Okay, so personally I would have gone with a different approach to this, but that's the way that it sort of it fell out in the end. So Express Tracer provides reference API, and I implement it within dtrace express. Okay, and then I create an express app. I attach the tracer to the app, and then to the instrumentation API in the app. I apply my DT instrumentation. Okay, so I know it's a bit, but that's standards for you. As soon as you get lots of people involved, you end up with that, and that's fine. And then normally, and then because it's top to bottom in Express, and what I mean by that is your middleware executes from top to bottom. So I have a start. So I want something to happen when I start. I've got an API, an app-get event, and then I'm using this res trace, some event and some event data. So I'm going to set up a USDT probe that's going to fire some event with some event data. All right. And the idea of this is, so you can see I'm using this res.trace, right? So the idea is that if I was doing this on a development machine or on a different environment, I can just I can swap out my tracer implementation for something that's more useful for the environment I'm on. So say if I was developing in Windows, which I do every now and again, but I still want to get log output or trace output, I can provide an additional trace implementation and provide that to this. And that's one of the benefits, obviously, of the abstraction. You can swap them in and out. Okay. So that is the Express application. Do I need to show you anything else? Yeah, let's actually have a look at so IBM's cloud is handily at cloud.ibm.com. Again, I have no internet. Ooh. That's not going to be a good demo, is it? It's a guest, yeah.
Yeah, intercom space guests.
Yeah.
Both words.
Capital A.
No, it's no good. Yeah. Sorry, would you mind telling me again?
Intercom, capital.
That's the name for that.
Phew. Right, yeah, so IBM Cloud, I'm not going to give you the full 9 yards on it, but it's a full cloud environment, offers everything from bare metal for years, all the way up to AI services, and everything in between. And from a Kubernetes perspective, we offer our own flavor of Kubernetes, and we also offer OpenShift as well, which is just coming into beta as well. So if you've got OpenShift in one place and you want OpenShift somewhere else or in IBM Cloud, you can do that on our environment as well. So I have a Kubernetes cluster set up. It has a single worker node. I should also add that you can log into this, so you can create an account, no credit card, and set up a demo worker node for free as well, which is nice. Now it only lives for 30 days. It'll die, but you can go and set one up again afterwards. So you obviously can't do production stuff, but if you want to mess around with Kubernetes, I'd argue it's one of the better ones for getting an understanding of Kubernetes from, because that's a good model. So this is it. I have a single worker node. Like I said, it's just a demo environment that I have, and I should. Be able to see my pods if I'm still done. Right, okay, yeah, so I have, actually we'll look at that as well. So up here in my DevOps environment for this application, I've got a spec I've got a Docker file, which is the spec of my application, which is just doing the usual Docker stuff. And I've also said, I've also got a deployment descriptor for this. Give me 2 replicas, call it hello app, all the usual sort of good stuff, and expose the port. It's not particularly complicated. And then I have a full sort of DevOps chain within IBM Cloud that understands that and will listen to Git commits and push it into the environment as well. So that's what I'm using to sort of get it up there. It's very sort of point and clicky type stuff. Right, so that's where that is. That's how it got up there. Then let's go back in here. So just confirm again. Then what all I'm going to do for this is I'm going to attach a probe to the running one of the running pods and create some traffic and monitor that traffic. Right? Seems handy enough. So I can stop that. So yes, I am going to go all the way through this. And if you don't do this, then I think you're lying. I'm going to get rid of this though. What do I call it now? Right, yeah. So this is, and it's a little unwieldy, and the reason why, actually I'll clear this off, I'll put it here. Yeah, hold on. So, basically what I'm saying is, actually no, that's not what I want. Let me go in here. There it is, yes. It's in the show notes. So, again, standard kubectl. The trace component is a custom build for my machine, but the source code is up on my GitHub. I will be trying to merge this back into the main branch. And what I'm asking it to do is run. I pass in this -u, which basically says enable the USDT types within the process on the server, and then execute dtrace express, which is the name of the provider that's associated with the tracer, and then give me the trace events associated with that provider, and every time it's there, print I fired and the arguments that were in. So we're just here now, and then attach that probe to a pod, that's the pod name. And then actually attach the console so I can get the output straight away. And then this last bit is basically saying, I'll pull this back up so that makes sense. And the last bit is I've had to implement a specific Bpf Trace container to do this at the moment, but it's basically saying go and use my version of the container to go on as an implementation of that. So this is it's very, very sort of extensible if you wanted to do different things in here than just, or you want to put some custom functionality within this node, you can do it, and Bpf Trace, kubectl Trace offers you the facility to go and do that. So, let's get this node here. So, sorry, this window doesn't have my cubicle configured. I'll just sort this one out. Now, this should. So apologies, a bit of debug input going on here, but that's basically gone off and provisioned that container for me. And there's no workload, there's no events firing, but hopefully, if I use Apache Bench, to go in here, here. No good. Right, yeah. Sorry. There's my service running in my cluster again. It's just a hello world. So if I Apache Bench that now. Mute console. That's firing some requests up there, and as you can see, those events that have been running within my internal node process in my container environment, I've now got hold of those within my local machine, and I can analyze what's going on in production, and I can turn on tracing automatically that debug tracing, or I can even look at the user stacks of the application if I wanted to as well. So I do have a UStacks demo, but I think I'm probably done. I think that's it. So I think the last piece then is that's great. So what's the future work to be done? So like I mentioned, this is all sort of all in my repo at the moment. I am looking to get this merged up into the Bpf Trace repo. So it'll be available to all the users of this project within the Cloud Native Compute Foundation. I'd also like to see some application-specific tracing in the samples that you get within projects. So most of the when you go and have a look at the trace samples that are associated with this, they're all at the kernel level, they're all at very much at the system level. There's not that much guidance about doing this at the application level. And one of the main reasons I think for that is because it's very sort of scenario specific. But I think we need to start sort of sharing the scenarios that we're seeing a lot in production and sort of educating each other on that. I mentioned previously, in order to get the inbuilt Node.js traces, you need a specific Linux build for that. I'd like to get that as a build. And there's a whole another talk I'd like to do about, or another piece I'd like to talk about, which would be how you do post-mortem debugging in containers. So when your applications crash, how do you get hold of that, the output of that, and how do you do analysis on that? But that is definitely for today, not for today. That's all I have, and apologies if I ran over, and it got a bit and the clicking around at the end, but I should have got my script shorted out a bit better. But hopefully you found that interesting. Thanks.
Thank you.